Hello, welcome to the second video in the Site VPN series. This one is going to be, we're going to be transitioning from static routing to BGP routing. I'm going to attempt to do this in a no downtime fashion because downtime is really bad. So we're looking to not drop any traffic at all between the peers. These are our tunnels here, if we remember correctly. And if we look at our desktop, we can see that I am. Quick explanation, so I'm actually RDP'd from this desktop I'm recording on to the London, which is the 192.168.0.180, and then on the 192.168.0.180 London, which we'll refer to from London as now on, I'm RDP'd to Chicago on the 102.2, and then in Chicago is a really weird way of them proving I've got two-way connectivity. I'm also pinging back to the desktop in London. Okay. So, as I say, the aim of this video is to transition from static routing, which is very boring and a little inefficient, however, it's still perfectly valid, to dynamic routing using BGP, as it's best suited for this type of connectivity, really, because it's typically third party. The admin guide to say does actually refer to OSPF, and OSPF, in fact, yep, again, perfectly valid, although I've gone BGP because it's typically this type of connectivity is going to be between sites or between companies, and BGP is more of a WAN routing protocol. And I have it on very good authority from a guy that I've been working with a lot recently who knows one hell of a lot more about routing than I do, that this is probably a more real-world scenario. You'd find that BGP is really the protocol you'd use for this, and certainly everywhere I've ever used dynamic routing for B2B VPNs between companies, it's always been BGP. And again, if you're doing cloud connectivity to AWS or Azure, that dynamic routing is always it's always handled by BGP. So BGP certainly seems to be the way to go. Okay. So how we're going to do this? A quick brief outline is we're going to keep monitoring our desktop, which I won't bore you with the details. I'll keep monitoring the desktop and show you occasionally. And then we're going to look to essentially bring up the BGP and the peers. So bring up the BGP across the tunnels, make sure we've got our peerings, then make sure our routes appear, and then finally, once we're absolutely happy that we've got a BGP route that we're going to fall back to, we're going to remove our static routes, and at that point we'll be on dynamic routing. Okay? So again, just to not to necessarily simplify things, because it doesn't, it complicates things, but because what I really want to do is I want to show our Chicago is a standalone firewall. It's not managed by Panorama, whereas our London one is managed by Panorama. And the reason I want to do that, and I'll continue to do that throughout when we're doing connectivity between two firewalls, is really to demonstrate both configuring it on a local firewall as well as doing it through Panorama, and just show the parity between the two and actually how good Panorama is as a platform. Okay, so on our Panorama, we're going to come to our network, which again, as we remember, is the same as network there. We're going to come to network under templates, and we're going to select our template for VM London. Remember, you can override in the stack now, but it's not something that we tend to do. Anybody's been doing Palo for a while. We remember the old mantra of configure the template, push the stack. Okay, I'm going to select our default virtual router. We're going to configure London first. I'm just going to make it larger so we can see it. And so we're going to go to BGP. I'm going to enable it, and we're going to give it a router ID. And our router ID that we have chosen for here is 172.22.0.5. Okay. It's a significant number, but it doesn't have to be. Doesn't play any part in the rest of the sort of IP configuration of the device. It just means we'll see that router ID in our routing table. And then we're going to have an AS number. Now, again, we're going to have an AS number because we're going to use eBGP. If we were using iBGP, they could be the same either side, so they'd be the same AS number because they're within the same autonomous system. Whereas what we're doing is in a B2B routing or a site-to-site VPN where you've got two separate sites, you then tend to look at it as having separate AS numbers, and it be eBGP as opposed to iBGP. So external BGP as opposed to internal BGP. So our ASN number that we've chosen for London is 64513, and there is some reserved private ASN numbers, because obviously AS numbers, BGP runs the internet, as we all know. So basically, there's a selection of private ASN numbers in the same ways as RFC 1918 addresses. That range is 64512 to 65534, and you can use whichever ones within that. Okay, so the next thing we're going to do is we're going to click install root. So we're going to make sure that any routes that this BGP configuration gets, we're going to install those routes, and we're going to reject the default route. So just in case the other side accidentally sends us a default route, what we don't want to do is we don't want to then send our traffic across that default route to the other side. And then we're going to create our peer group. Now peer group is so this is now our connectivity to the other side. So what is the other side going to be configured as? So we're going to call this our Chicago peer. We're not going to remove the private AS. That strips the private AS numbers from the path. This is essentially a peer-to-peer link anyway, so it doesn't really matter, but we're not going to do it, so we're going to remove that to allow those private ASs, and I'm going to call this Chicago primary. Now peer AS is going to be, I've written this down, I'm all well prepared, you see. So our peer AS, that's going to be configured on the other side, 64512. Okay, and the interface that we're going to use to peer across is going to be the tunnel 20, because remember this peering is going to go across the VPN. And then we can either have, if that's got multiple IP addresses on it, you can allow just any IP address from there, or you're going to select the IP. In this particular case, we're going to select the IP, which is our tunnel IP. The tunnel IP is 172.22.02, and that's going to be our local tunnel IP. And then the other side is going to be 172.22.0.1. So now we've got the peer address as well. Okay, and we're going to OK that. Okay, and that should be enough now to bring up our peer. So again, because this is on Panorama, so we can do it. We can do a commit and push. We'll do that here. We'll do a commit and push here, and we'll notice that the push scope to the firewalls doesn't exist, and that is because if we look at our templates, which is our stack VM London template, it's still claiming it's in sync. So if it's in sync, then the flag isn't there to put it to be pushed, because as far as it's concerned, it's got the same configurations on the firewall. We can select that here, and then it will be in there, and then we can commit and push. And then that will commit to Panorama, and then it will push it to the firewall. Whilst that's doing that, we'll come back to our Chicago, and again our network virtual routers. I'm going to select our default virtual router. We're going to enable, and our router IP, router ID for Chicago is going to be 172.22.0.6, and our AS number, as we configured it previously, 64512, because that's the side. That's what we've told the other side. We're going to reject the default route. I'm going to install the route as we did previously. And we're going to create a peer. What did I call the peers on this side? Let me just check. Okay, so if I quickly come in here, this is just to keep the naming standard the same either side, so we can check on BGP and peer group, and I did it in lowercase and 2 numbers. So we're going to call this the London peer. Okay, I'm not going to remove the private AS, and we're going to call this London primary. The reason we call it London primary is if you had 2 tunnels up, and that just comes from me doing this as like at work basically. So you have 2 tunnels coming up. You have 2 redundant tunnels. You have a primary peer and a secondary peer, and our peer AS is going to be the 64513. Remember, that's the opposite side because this is what we're peering with. And then we are going to go over our tunnel 20. Going to give it that IP address that we're going to be going from, and then of course the IP address is the IP address on the corresponding side, corresponding. Is that the correct term? I don't know it is. Okay. And OK. OK, so now our peers should come up once this has been committed. So I'm going to commit it here. And it does look slightly different. The reason it looks slightly different is because our Chicago firewall is version 11, whereas our London firewall is version 10.2. Okay, so now that's completed both sides. So now we're going to go and confirm that we've got our peers up. We can see, if we just refresh this, we can see now that we've got another bit of information within our default router. So previously we didn't have this. But what we've got here, we've got BGP is now enabled. We've got a peer count of 1 and a peer group count of 1, and that's the configuration we made previously. And we should have this on the other side as well. Okay, and then if we want to go and have a look at the peerings, make sure if it's a Panorama managed firewall like London is, make sure that you're on the firewall itself. Okay, then we simply go to more runtime stats, and just to demonstrate, so if we come back to Panorama and we look here, so we can refresh this now. There's nothing here. We have nothing. There's no more runtime stats or anything, so it all has to be done from the firewall. So we click on more runtime stats. We come into here, we come into BGP, and we can see we've got a summary of the BGP, and we've got our peers, and it's established, and we've got our peer group, and we can see our Chicago peer group, and the type is eBGP. There is no local RIB as yet, and we'll get to that, and there's no RIB out as yet, so that's our routing information base. That's what we have, that's our route, and then we have the RIB out, that's what we're advertising to the other side. And so we'll see just quickly, just to confirm, we've got the same here as well. Probably somebody can, I don't know, maybe somebody can correct me, but I very much doubt you'd have one side showing up and established and the other not. We've got a peer group there. We're not removing the private area. So a lot of this stuff is what we configured. You can see this all within this status, and we've got local RIB. Okay, so now we're happy that our peers are up, and now that we're okay that we can go ahead and move on to the next one. What we'll do is I'll just quickly show you how to confirm this as well through command line. Okay, so here we are now on VM London. So we are going to do a show routing protocol. We're going to use protocol because we're going to be looking at the BGP protocol. So we've got peer or peer group. We're going to use peer because we want to look at the peer on the other side. Then we just have to select the virtual router, which is the default virtual router. And now we've got all the information about our peer on the other side. Again, the peer router ID, which is 2206, remote AS 512, Chicago peer and established, how long it's been established for, and so on. And if we just take that command and throw it in there, of course, we've got the same on the other side. So now we can see from the GUI as well as the CLI that we've got a good peering. Okay, so the next step now is we're going to now put some routes into it. So we're going to come back again to our default router. And this is, I just want to take just a quick second just to tell you, so basically this is going to work because of this. So we have administrative distances there. Anybody knows about routing will know what administrative distances are. For people who don't, that's basically the values of which the firewall is going to use. In this particular instance, the firewall is going to use to choose the route that it installs and the route that it then uses in its forwarding base. So static is 20. So that means, static is 10, eBGP is 20. That means that essentially the static route is going to beat the eBGP route. So what we can do is we can put in our eBGP routes and it will still use this static route it's got here until we decide that it's time for it to change. Okay. So the way we're going to do that is we're going to create a redistribution profile. The redistribution profile is essentially what we're going to do is we are going to say, I'm going to call it connected. Just a quick note on the side here. So no redist makes this a no redist route. So it's everything apart from what is selected in here. Redist makes this a redistribution profile, which means we only redistribute what is selected in here. You can't have a no redist profile just on its own. You have to have a redist one for the no redist to work. We can go into this later when we do more sort of modules on actual routing. Okay, the priorities, one, we want this to be looked at first, and we're going to select connected. And then we're going to put our interface, which is our LAN interface, we're going to put our 1.2 into there. So what we're saying now is that we want to, no we're not, because I haven't clicked that. So what we're saying now is we want to redistribute our connected interfaces into what's going to then become into BGP, because we're going to use a rule. Okay, go to BGP, and we have to click on redistrals. So this is the rules that we're using for our BGP instance, and do that. Simply click add. And we see that that nothing comes up. Okay, and I'm glad it did that, because I actually caught this in the practice for this video, and I just want to show you again because I'd forgotten all about it. So there would appear to be a bug of sorts within 11, which means it doesn't work that way around. So what we're going to do is we're going to delete this from here. Okay, we're going to come back to BGP and go to our redistribution rules, and then we're going to add a redistribution rule from here. So what we're going to do is we're going to do new redistribution profile. You'll notice it takes us back to exactly the same window. We're going to give it exactly the same configurations. We're going to tell it to redistribute and connected, and we're going to select our interface, which is our LAN interface 1.2. Okay, I'm going to click OK. That's going to come back, and then that's going to be our connected redistribute. So basically now what we're saying, telling BGP, or at least this instance of BGP, is that we want to redistribute our profiles in here. And see, we come back here and we've got this random odd cloning of things. So we're going to delete those. Okay, and then you can see that it's just basically populated it in the same place. Very strange. Not quite sure what the script is with that. There must be something in the background somewhere. Okay, so that's it. So that's what we're going to do. So we're going to redistribute our connected into that. I'm going to hit OK, and then we're going to do a commit on here, and then we'll go to our panorama and do the same. And we'll see on here that this one will actually work. So this is going to be connected redist as well. Going to give it our priority 1. Redistribute and add our interface. Okay, and then on our BGP, and do our redistribution rules, and then we're going to simply select it there. All good, so that's how it should run. Okay, and then we're going to do commit and push again, and then we'll have the same thing again where it doesn't have a selection, because as far as it's concerned the template is in sync, but we know it's not. Okay, then we're going to push them out, and then once they've pushed on both sides, we should then be able to see those connected subnets either side. Okay, so now they've committed on both sides. Clear that off, and now we can start to look at our routing tables and see that, you know, what that result has been. Okay, so we've got a local rib prefix count of 2 now, whereas we had 0 previously. Okay, we're going to go to BGP. We're going to look at our local rib. So our local rib, if you remember, is our local rib. This is our side. This is what we are going to. Sorry, this is Chicago side. This is what's been sent to us, because the peer is Chicago primary. This is our side, which is local. So we know that's being advertised to us by Chicago primary. And we've got a rib out, so that's what we're advertising out to the Chicago primary. And if we come back to the routing base, we can look and we can see that we have a question mark next to B, a big B for BGP, because that isn't the active route. That's not currently active. The currently active route is going to be the static route, which is there. So we've got 2 routes in for this now. We have 102.0.25 on a static, the metric is 10, and then we have this, which is just loose. It's not even been really evaluated yet, because we know it's going to the same destination, but it's not installed because that's lower. Okay, and we have the same thing on the other side, so we just quickly refresh that over. Just a side note then, when you're working with it, this does not auto refresh. So if something changes within your virtual routers, and I'm sure that you'll find it in other places as well, you have to refresh it before you can see the latest configuration. And just quickly, we have the same thing here. So we have the London side here. We've got a static, which is there, which is winning at the minute, which is tunnel 20, and we also have the question mark over the BGP. And then again, BGP, we've got local RIB, which is what's being advertised to us from London, if I can get my stuff the right way around this time, being advertised to us from the London peer, and then we've got our local that we've got there, and then of course we are sending out the 10.100.102.0/25, and we're sending that out, and we know it's advertised. Okay, so now we know our routes are all there. If we just come back here, we can see that our ping is still going. And we know that we've got verification of two-way traffic across the VPN tunnel because I'm RDP'd onto London, and then from London I'm RDP into Chicago, which is the 102.2, and then in Chicago, which is this desktop here, I'm pinging back to London. So we know that we have full communication, nothing has been disrupted as yet, and indeed we can see in our IPSEC tunnels, we can see that all is well. So, sorry, I'll just show you the IPSEC tunnels there. I forgot to click it back. So we can see in our IPSEC tunnels that all is well. So what we're going to do now is we're going to remove the default route. When we remove the default route, we should be able to just see that now we have our BGP route that's being used and installed, and it'll have an active against it, and we'll have no static route, and with any luck and a good following wind, the tunnels will stay up and the traffic will continue to flow. So we're coming to virtual routers. This is on our standalone side, static routes. Okay, so this is our London route. We just expand this, make it bigger. This is our London route. This is our static up tunnel 20, as we know. We're going to pull that. By pull, I simply mean delete. And then we're going to commit that on this side. And because we now have those backup routes within our routing tables, it doesn't really matter which way round we do this. So I'm going to pull this one as well from VM London. VM London, obviously, because we have to commit to Panorama and then push to the firewall. It's going to take longer, so Chicago will finish first. So we're going to pull our Chicago static route from here. Okay, do our thing again. And this is sort of, we need to qualify that as well, I suppose, a little bit more. When we say that we're going to commit and push it, when you're actually waiting for three things to happen, although one of them happens very, very quickly. So the commit to Panorama is basically, as it says, it's committing to Panorama, so those changes now reflect on Panorama. And then the push, the actual push, is simply sending that XML down to the firewall. Once that XML gets to the firewall, it's not Panorama. Panorama doesn't actually sort of push it on and then push it into running configuration on the firewall. There's in a local commit that is done on the firewall to get that candidate config into the running config, which is why not oftentimes, well, it depends how bad your day's going. Sometimes you'll see that you can have no commit errors at all on Panorama, all is well, and then you send it to the firewall and suddenly you get this commit error from the firewall and it doesn't work, and that's because it's pushed on the firewall. Okay, so that's committed to Panorama there, see how that's doing. Okay, so now we know that we've got, because that's only just committed to Panorama, and if we look on our firewall, London firewall, we should see a commit being triggered, because the communication of the XML is actually fairly quick, because XML is XML. So that we know that still hasn't been committed on our firewall. And yet, if we come back to our desktop, and yes, I did quickly check it first to make sure it's still going. Come back to our desktop, we can see that the ping is still going and all is well. Back to our firewall, refresh it, more runtime stats, and now we can see the static route for, this is Chicago, so obviously our side, the other side is the 172.16. Our static route has gone, that's disappeared completely, and now we've got an active and BGP. Our forwarding table for 172.16 is going to be tunnel 20, because of course that's where it's going. And in BGP, we have everything all exactly as it was. So we now know that we have the routes in place. We know that on Chicago side at least it's BGP. We'll have a look and see if London has finished pushing or committing. I keep saying pushing. Pushing's a checkpoint term. I used to like checkpoint. Okay, so we're on 98% there. So that should be committed in a second, and then we can do the same validation on VM London. And once we've done the same validation on VM London, we can then wrap the video up, and you can go about your daily business after watching this. Okay, so that's now completed on London as well. We can see our session is still up. I can open a browser in Chicago. In Chicago from London. So the VPN's still going, the ping's still going. So we have successfully migrated from static routed VPN to BGP. And then if we wanted to put something else into BGP, we'd simply add another connected interface or create some export rules for our advertisements. Remember that export rules do have to have BGP requires that actually be a valid route, so you have to have the IP address or whatever it is you're using within that, and that's it. That's it. So we've done that. As you can see, there's no static routes on here. See, perfect example there again. I did it for you guys. I perfectly provide an example of how you have to refresh the virtual router configuration in the GUI because otherwise it shows you what was there before. So we've got no static routes, and our VPN's working. Okay, so I think we're going to look at a lot more around these. We're going to change the IPSEC. The IPSEC ciphers and things like this, because I don't know if anybody's noticed, but actually my IPSEC tunnel there is using, just quickly show you, so it's using the default crypto, which is, if we look on here, default crypto is 128 CBC and 3 DES, SHA-1 group 2. I mean, you just absolutely, in no world would you use that. We've got to bear in mind, of course, that if we do change that, that isn't going to be zero downtime unless we can get another tunnel alongside it to another peer, and then you could maybe move across. Maybe we should look at that, I don't know. But yeah, so there's lots more to do with site-to-site VPNs, so please like and subscribe. Should have said that at the start, really, because very rarely do people watch this far down. Please leave a comment below that you've watched this far if you have, because that would be awesome. And I will catch you in the next video.